Okay, let's take a look here at 8.6, kind of our last set of or lesson for this unit. And again, this is kind of what we've been building up to, everything we've been doing. Again, a quadrilateral has 4 sides. It's kind of got 3 sets. We've got trapezoids, which again have 1 set, or the bases, the top and the bottom are parallel. So B1, B2, parallel. And then if it happens to be an isosceles trapezoid, we have our base angles are congruent. I'm going to try to shorten it, which again means this angle is congruent to this angle, and this side is congruent to this side. Maybe we'll make that a different color. So those 2 sides are the same. And then we also have the diagonals are congruent. So our diagonals are congruent. Parallelogram is probably the most broad term besides a quadrilateral. There's a lot of things that happen with a parallelogram. We have opposite sides being parallel. Again, 2 straight lines up in the air is the symbol for parallel. We have opposite sides being congruent. We have opposite angles being congruent. Same side interior or consecutive angles. Let's just say same side, not interior, but same side angles are supplementary, which again means adds up to 180. And we have the diagonals intersect at the midpoint. And then for our kite, we have a few properties. We have 1 set of congruent angles. So 1 set congruent angles. And those are going to be like our non-vertex sides. So those 2 angles. These second sets, these 2, this one and this one, are not congruent. So not congruent, those 2 angles. Only the orange. Maybe we'll write that orange. Well, let's write it in orange. And then we have perpendicular diagonals, which again means the diagonals meet at a 90 degrees. Now, when we kind of think about combining the parallelogram properties and the kite properties, we end up getting a rhombus. So again, all these properties of a parallelogram, and a kite can sometimes make a rhombus. Again, that's why we have that red line, whereas a rhombus is always a parallelogram. A rectangle is always a parallelogram. So the black line means that it is always true. The red line means that it's sometimes true in specific cases. So again, we have the 4 congruent sides on our rhombus. We have diagonals perpendicular, which again is a property of the kite. And then we have the diagonals are angle bisectors, which again is can be kind of part of the parallelogram. And again, bisect means cut in half. Rectangles are going to have 4 right angles. So again, technically, a rectangle is an isosceles trapezoid. Technically, a rectangle is a normal trapezoid. Technically, a rectangle is a parallelogram. And then our ultimate quadrilateral is the square, when a rectangle and a rhombus have a baby, and all of these properties of parallelograms, rectangles, and rhombuses are true, whether it's about diagonals, whether it's about angle bisectors, whether it's about parallel sides, congruent sides, it's all true. Quadrilateral, DEFG, has at least one pair of opposite sides congruent. What types of quadrilaterals meet this condition? One pair of opposite sides congruent. Well, opposite sides of a rectangle, a square, a rectangle. Again, I'm following the family tree kind of. Opposite sides congruent. I guess technically an isosceles trapezoid would have opposite sides congruent. Could potentially be an isosceles only. That's got to be isosceles. We could have a parallelogram. We could have a rhombus. Opposite sides of kites are not, because kites are consecutive sides. So again, these two sides and these two sides would be congruent. So as far as a kite, we're going to say no. But what did we get? 1, 2, 3, 4, 5 different examples of that. Give the most specific name for this quadrilateral. Explain your reasoning. Again, I see consecutive sides being congruent, and there's only one shape that talks about consecutive sides being congruent, and that's a kite. So this number 2 is a kite. I notice I have parallel lines, so immediately I can cross off a kite. So I'm thinking trapezoid, parallelogram, something in those families. Okay, I see that the midpoint is not it's not in the middle, whereas diagonals for parallelogram intersect at a midpoint. Since that's not true, it's not a rhombus, it's not a rectangle, it's not a square. Therefore, my only choice is it a trapezoid or an isosceles trapezoid? And because I don't know what those sides are, but I know it's not going to be the same, because again, if I were to create a triangle here, I have 62 and 80. This triangle uses 64 and 75. They're not going to be the same. So this is just an old-fashioned regular trapezoid. Over here, I see that I have the diagonals are found at the midpoint. So that's going to be true for both. And I have one set of congruent sides over here. I don't know about this other set, DC. I'm unsure about that one. But I would say that because we have the diagonals intersecting at the midpoint, and we have at least one side, we have one set of parallel lines, which again, if we know the midpoint in one set, then we can assume that this side is also, excuse me, it's not parallel, it's congruent, but we can assume that this side is going to be congruent. The only thing is we don't know anything about these angles. That's why I don't believe we can call it a rectangle, because we don't know anything about the angles. So we're just going to go with a parallelogram.